Just like regression, I won't explain this in more detail because we have so many things to tackle. Normally, I dedicate like one full session for this, but just think of logistic regression as the classification version of linear regression. There are some nuances, but if you understood linear regression, it's pretty much like that. So I have only a few slides here to emphasize that. In linear regression, your y is equal to theta times x, right? In logistic regression, you're simply adding this sigmoid or logistic function in the output of your linear regression. Yeah, you just add one more thing. You apply that logistic function, and then that's the output for logistic regression. So that's why I said if you understood linear regression, more or less, you're good with logistic regression. In linear regression, you're returning a continuous value. In logistic regression, well, technically it returns continuous values as well, but it has probabilistic interpretations. And you could specify a threshold. Say, for example, 0.5. If it's higher than 0.5, then that's like positive. If it's lower than that, it's negative. Okay, I have to show you logistic function first. So, sorry, I have to go back. I don't have, oh yeah, this is the equation. So it's this 1 over e raised to the negative of the output of linear regression plus 1. That's the logistic function. It's this one. So for example, this is the output that you have in your linear regression. It's this blue line here, similar to the ones that I've been showing you earlier. But now you're applying the logistic or sigmoid function. So you squish those data into this curve here. And that's going to be your new value. And think of it as probabilities. If you apply the sigmoid function, then you have 1 as your upper bound and then 0 as your lower bound. So if you simply put your threshold as 0.5, anything lower than 0.5, then that means like it's negative. If it's higher than that, it's positive. Now you have binary classification. You can now classify it. So yeah, this is simply the classification version of linear regression. Following so far? Okay, just some equations for binomial and multinomial or softmax regression. But yeah, it's really just this. You're transforming the values of linear regression into this logistic or sigmoid function. So you end up with values ranging from 0 to 1, and your threshold is 0.5. And because of that, you have turned your linear regression problem into a, your regression problem into a classification problem. Thumbs up if you're okay with that. If you have understood what I have just said. Okay, I guess no one understood that. For example, your input is 0.25. Based on our line, the output of linear regression, if you have 0.25 as your x, then your y should be more or less 0.3. But we want to turn this into, say, a classification problem. With this 0.3 y value, well, actually we don't have, yeah, basically the 0.3 y value here. What is it going to be after you apply logistic or sigmoid function? You just look at the line here, 0.25. Based on the logistic function, it's now going to be, I don't know, 0 point something, very low value. Our threshold is 0.5. Anything lower than 0.5 is negative class. So I don't know what the context of the problem is, but if you have that, then we say it's negative. Say, for example, you're trying to predict if it's cat or dog, or maybe something more relatable for this problem. Think of this as maybe like if it's gonna rain tomorrow or not. If the value of x is 0.25, then it says, okay, it's not gonna rain tomorrow because the new value is lower than 0.5 threshold. But what if your x is 0.75? Well, you can already see it here. Of course, it's above the threshold that we have. So it's it will say, the model will say that it's gonna rain tomorrow. That's what logistic function does. We're simply transforming your original values into this 0 to 1 range. And now you could think of it as probabilities. Anything lower than 0.5 is positive. Anything lower than that is negative. That's just it. Following? Thumbs up if you understood that. Okay, great. At least I can see some thumbs up now. And that's it. This one you could just ignore, but you have the equations here.